everyone, welcome to Samadhan Life Science. Today we will discuss about rate equations from reaction kinetics chapter. So let's start with rate law. That is the relationship between the reaction rate and the concentration of reactant. So if we have a general reaction here, A plus B is forming the products, then we can write the rate is proportional to concentration of A to the power m into concentration of B to the power n. Now this m and n are the order of the reaction with respect to A and B. Now what's the order? Order is how the reaction rate is depending on the concentration of the reactants. Now this order is different from molecularity. So let's first discuss molecularity. So I will take an example reaction here, CH3 COOC2H5. This ester is reacting with water to form acetic acid and ethanol. Now for this reaction, to calculate the molecularity, first we have to check if it's balanced. So now this reaction is already balanced. Now we have to find out how many molecules are colliding or reacting here to form the product. Here for this reaction, 1, 2 molecules are reacting. So the molecularity for this reaction will be 2. But the order for this reaction is not 2. Why? Because order is how the rate depends on the change in concentration of the reactant. Now for this particular reaction, the rate depends only on this ester and not on water, because for this hydrolysis reaction, this reaction is happening in aqueous medium and the amount of water in the reaction is so large that the change with time is negligible. So the rate only depends on the concentration of only one reagent. So the order here is 1. See, the order and molecularity for a particular reaction can be different, and this order we can only determine experimentally. We cannot predict it by any formula. Okay, now let's go back to the rate law. So I wrote that a rate is proportional to concentration of the reagents. To break this proportionality, I will take a constant, and this constant is a rate constant. Now for this particular reaction, overall order will be m plus n. Now for example, if the rate is proportional to concentration of reactant to the power 1, then this is a first order reaction. If the rate is proportional to concentration of A to the power 2, then this is a second order, and you can go on. Now we can demonstrate this rate in a different way. So the rate can be equal to change in reactant or product concentration with change in time. So for this general reaction A plus B to C, I can write the rate is equal to minus 1 by x, change in concentration of A in time t, so by dt. So why this negative? Because with progress of reaction, the reactant concentration is decreasing while the product is increasing, right? Now we can write this rate like this too, with respect to B, also with respect to the product. For the product, the sign will be positive. Now we have two forms of rate. Now let's combine those. So I will take a first order reaction first. So first order reaction, A is forming product. So the rate is equal to K into A to the power 1 or A. And also the rate is equal to minus change in concentration of T in for change in time, T time change. Now let's rearrange this equation first, and then we will integrate both sides. So for this side, integration from initial concentration to concentration at time t, and for time 0 to t. So we will have this equation, ln A minus ln A0 is equal to minus kt. This is the rate equation for first order reaction, and this is very important for you guys to solve the numerical problems. So we can write this equation in another form. So concentration of A is equal to initial concentration into e to the power minus kt. This is for first order reaction. In a similar way, we can get the reaction rate equation for second order and zeroth order. So for second order, rate will depend on concentration of reagent to the power 2, and for the zeroth order, rate will not depend on the concentration of the reagent. It will only depend on the rate constant. That means the rate is constant throughout the reaction. Now let's take an example from your previous year question. So first, for this first question, for a reaction 2A to B, the concentration of A decreases from 0.1 molar to 0.05 molar in 10 minutes. If the reaction is first order, find the rate constant K. Now in the question it's mentioned that the reaction is first order, but the reaction is written as 2A to B. So don't get confused. Only consider what's written in the question. So for the first order reaction, we have this equation ln A minus ln A0 is equal to minus KT. So we will put the values. So ln 0.05 minus ln 0.1 is equal to minus k into 10, and this k will come around 0.069 minute inverse. Now this unit of k can be different for different order reactions, so be careful there. Okay, now let's go to the next question. So a reaction of second order with respect to A is with respect to A, the reaction is second order. Now the initial concentration as and K are given. Find the half life. So for the half life at T equal to T half, the concentration, initial concentration is A0. At T equal to T half, A0 becomes exactly half amount. So at what time the A0 is becoming half concentration of initial concentration is our half time. Now we have a equations, we have formulas for to calculate the half life. So for the second order reaction, I will write the formula that T half is equal to 1 by K into initial concentration. So we'll put those 0.2 into 0.5, and this is 10 minute. Okay. Now for the last question for today, the reaction of a rate is independent of the concentration of the reactant. What is the order? We already saw that. For the zeroth order, the rate of the reaction is independent of the reactant concentration. So the answer here is 0, zeroth order. So that's all for today. I hope you understand the rate equations. Thank you for watching. See you in the next video.